This is Carol. Welcome to my presentation 1, Unsolved Number Theory Problem. This is for Math 435, Theory of Numbers at Mayfield State University. I'm recording this presentation in spring semester 2023. So, I've been fascinated by prime numbers since I was a child. So this is the first part of my presentation. I do want to talk about the charm of prime numbers through a poem. And I found this poem during my research. It was written by Helen Spaulding, and it was published in 1961. It has a title, Let Us Now Praise Prime Numbers. And this is the first stanza. Let us now praise prime numbers, with our fathers who begot us. The power, the peculiar glory of prime numbers is that nothing begot them, no ancestors, no factors, atoms among the multiplied generations. So as you can see, prime numbers can be poetic and mysterious. So I chose to work on Twin Prime Conjecture, and here is my presentation outline. So I'll be talking about the Twin Prime Conjecture, and I'll be talking about its historical development and some fascinating images of twin prime functions in this presentation. So, what is the twin prime conjecture? It states that a set of two primes that differ by 2 are called a twin prime pair. That is, we can represent that as P and P plus 2. Here are some examples of twin primes. So for example, 3 and 5, 5 and 7, 11, 13, 17, 19, and so on and so forth. So the conjecture goes like this. There are infinitely many twin prime pairs. So, well, this sounds reasonable, but how can one prove that? In fact, as early as 300 BC, Euclid suggested that there were infinitely many prime numbers. In the year 1849, Alphonse de Polignac formed this conjecture. And in 1912, Edmond Blondel published a list of unsolved number theory problems. And as we can see from here, all of them were related to prime numbers. So for example, the Goldbach conjecture states that can every integer greater than 2 be written as the sum of 2 primes? The Legendre conjecture states that there always exists at least one prime between consecutive perfect squares. And here's another one. Are there infinitely many primes of the form a squared plus 1? So, with the advancement of computer technology, recent mathematicians had some breakthroughs in the 2010s. For example, Ethan Sen in 2013 proved that some integer n greater than 70,100, there are infinitely many pairs of primes that differ by n. And James Maillard, he also mentioned his fascination about prime numbers and some breakthrough about this conjecture, and also his collaboration with Terry Tao in one of the number-file interviews. The most recent breakthrough was in 2019. So these two mathematicians, Solving and Schusterman, they used finite fields or the geometry of primes to proceed in solving this conjecture. So this is their theory about the geometry of primes. So while this method seemed to help us visualize this conjecture, it remained unsolved until now. Also, some mathematicians use functions to investigate the patterns of this conjecture. So as example here, the function starts from 6n plus 1. As more twin primes join the Cartesian plane, as we can see from here, it becomes more and more complicated. And then we're asked if we can find any patterns, either in the intervals of finding twin prime numbers or finding the end of twin prime numbers. So as example, this is the first 20 twin prime functions. So with the current technology, this is what can be found now. As we can see from here, the largest twin primes found today with its 388,342 decimal digits is these two numbers. Well, while the conjecture remains unsolved, and it was not able to pinpoint why it has been so difficult to solve, here is my conjecture. Just like we cannot find the end of numbers and we have to use infinity to represent the remote reality, perhaps this conjecture will remain mysterious until the next wave of technological advancement to be solved. So here's the final stanza of the poem I read earlier, and I think this concludes beautifully the mysterious nature of prime numbers. So here we go. All prime improbable numbers, long may formula hunters steam in abstraction, ways to skeleton patience, stay nonconformist, nuisance, phenomena irreducible to system, sequence, pattern, or explanation. Thank you for listening to my presentation, and these are my references. Thank you. Until next time. Bye-bye.